As I mentioned in previous videos, the last video, that when you make a hypothesis testing, there are steps required to do this hypothesis testing, procedures required for testing your claim, your hypothesis. So the first step is stating the null hypothesis and alternative hypothesis. That already I have explained how to decide what is your null hypothesis and what is your alternative hypothesis, what is your H0 and what is your H1. Step number 2 is selecting alpha. What is this alpha? Alpha is called level of significance. It is a value that you decide based on the problem given to you. Because most of the time you can see that you will observe that this value already given in the problem. So this level of significance, it tells you that this percentage you have, you might make a mistake, or you might reject the null hypothesis where it is true. So you might make a wrong decision. So you have this percentage that you might make a wrong decision. Step number 3, decide which distribution or which statistic to be used in your problem. So as I told you, this is a statistical problem. So in a statistical problem, you should know that for this data, what distribution I have to use. Okay, so step number 4 is the rejection region. So when you should reject the hypothesis, there should be a region or a value. On that value, you should reject your null hypothesis. So how we find this rejection region? You will be given a table based on the distribution you use, and then you decide what is the rejection region for your problem. Step number 5, compute the test statistic, or we call it calculated value. How you compute this? You will be given information about your data like sample mean, sample variance, or population variance, and sample size. So these information are given. There is a formula you use for test statistic, and that you will find the calculated value. Now, how you make the decision? If your calculated value, which you found it in step 5, is greater than the table value which you found it from step 4, then in that case you have to reject the null hypothesis, whatever is your null hypothesis. If the calculated value is less than the table value, then you don't reject the null hypothesis. I can say that we accept the null hypothesis, but most of the books, they don't write accepting the null hypothesis, but they are writing do not reject, which has the same meaning of accepting the null hypothesis. Now we will take an example to understand all this procedure. So we are now going to move to the example. A chemical plant is producing carton of substance, and mean carton weight is supposed to be 2 kilograms. The production manager suspects that the filling machine is not working properly. From past experience, the standard deviation is known to be 5. So this is population standard deviation because it's taken from the past experience, and this is the population mean. Now in this paragraph we are talking about the random sample of 30 cartons. So this value is the sample mean. Found the sample mean is equal to 0.989. Test the manager's suspicion at 5% level of significance. So this is our alpha. So 5% level of significance. It means that there are chances of 5% the decision you are making is not correct, and you are 95% confident that whatever decision you're making is correct. Step number 1, state the null and alternative hypothesis. So null hypothesis we always write as population mean equal to the value which is given. So in this case, in this problem, we are going to say that mu is equal to 2 kilograms. So already the mu is given as 2 kilograms. Alternative, as you see that nowhere I mentioned whether the manager is testing what. He want to test that the filling machine is not working properly. So what we are going to do, we don't know whether it's producing more than 2 kilograms or less than 2 kilograms. So he suspect that it is not working properly. So in alternative, we will write that the population mean is not equal to 2 kilograms. That is our step number 1. Step number 2, select alpha. So we don't need to select alpha in this problem. It's already given us 5% level of significance. Now step number 3, as I told you, which distribution to use in this problem. Now there are 3 conditions. First, if your sigma population variance or population standard deviation is given, then this data or this problem is, you can use a normal distribution. And then if you use a normal distribution, it means you are going to use your test statistic as Z, and this is the formula for the Z. You will be given all the values, you just substitute these values and then you get your test statistic. Suppose sigma is not known. So what distribution we have to use? So there are 2 cases. If sigma is unknown, you have to look second step at your data. If your data is large, how large your data should be? If your data has more than or equal to 30, then you use again normal distribution. So you approximate your data into normal distribution, and then again you use test statistic. That is the formula you use. You can see that these 2 formulas are same except here. Why I'm not using here sigma? Because already I said sigma is unknown. So you will be given a value for your sample variance or sample standard deviation. So this value will be for sample standard deviation. It will be for large sample, which is more than or equal to 30. Now again, as I told you that when sigma is unknown, you have to look at your sample size. So suppose your sample size is small. How small your sample? If it is less than 30, you can't use normal distribution. You have to use another distribution which is called T distribution. In that case, your test statistic is T, and then this is a formula. As you can see, these 3 formulas are same, but so this is a formula we use for test statistic, but when you are writing, you should write here x bar minus mu over S small. So S small refer to the T distribution, and it's referred to the sample variance when you are using the T distribution, divided by square root of n. So in this problem which I gave you, you can see that standard deviation for the population is given. So we know our standard deviation for the population. So standard deviation is known and it's equal to 5. And so we don't need to go to the next step, what is the sample size. So if standard deviation is known, population standard deviation is known, then you can use normal distribution. All the information is given to you. So you have to compute your calculated value, which is called test statistic. Okay. Now find the critical value or the table value from the table. So it depends which distribution you're using, and it's also depends what side you are using. Are you using one-side test or two-sided test? When your alternative hypothesis has an equal sign, it doesn't have greater than or less than sign, in that case you use two-tailed test or two-sided test, because you don't know, you are testing whether your machine is producing more than 2 kilogram weight or it's producing less than. You want to test that it is not equal to. So whenever you see the symbol not equal to, it means your test is two-sided. So if we know that our test is two-sided, then I can find the table value from the table. This table will be given to you. This table is for the t-distribution. Only the last row gives you the value for the normal distribution. Normal distribution, the z value, I mean. So how we use this table? First of all, I told you it is two-tailed or two-sided test. So that we have to go here, two-tailed. Now these value are the alpha value. So in our case, our alpha is 5%. So that is 5%. It's 0.005. Since we are using normal distribution, so we go to two-tailed 0.005. Then we go to the last row. We find that our z is equal to 1.960. So if you see this is called confidence level. If your alpha is 5%, it means your confidence is 95%. So this is the table value for the z. So we have the table value, which is 1.960. How we can get the calculated value or the test statistic, because based on this we will make the decision whether to accept or reject our null hypothesis. So already we have the sample mean, we have the population mean, population standard deviation, and the sample size, which is n equal to 30. Computing that and getting the absolute value, you get that it's equal to 1.11. Now, the table value is 1.96 and your calculated value is 1.11. As I mentioned before in the procedure, when the calculated value is less than the table value, in that case, you do not reject the null hypothesis. So what is our null hypothesis? In the null hypothesis, we are saying that the mean is equal to 2. So if you don't reject this, it means you are accepting the null hypothesis. So it means, in other words, that there is no enough evidence to conclude the manager's suspicion that the mean of the weight is different from 2 kilograms. So that's the way how we solve the hypothesis testing question. I will make another video for the next example.